Today, let's solve problems by finding equivalent ratios. Take a look at these dots. The ratio illustrated here is 3 to 6. 3 red dots for every 6 green dots. But, is it true that we can come up with another ratio from these very same dots? What about 6 to 3? How so? Well, 6 green dots to every 3 red dots. Is there any other ratios we can come up with? How about 3 to 9? There are 3 red dots for every 9 dots. We could write it like this. There are 3 red out of every 9 dots. And can you come up with one more ratio? How about 6 to 9? 6 green dots for every 9 dots. Written out, there are 6 green out of every 9 dots. Do you see how we've been using the whole to make a new ratio? With this one simple illustration, we came up with 4 different ratios. We used part to part, and we switched the parts. We used the whole to part and a whole to another part. Many different combinations just from this one illustration. Let's use this knowledge in a problem. So there's a government official. He wants to know how many cars are on the road. He finds out that there are 192 registered vehicles on the road. This is a combination of trucks and cars. The ratio is, for every 5 cars, there are 7 trucks. The question is, of those 192 vehicles, how many of them are cars? And how many are trucks? Here's the ratio we've been given, 5 cars to every 7 trucks. But, because we know that there are much more than just 5 cars and 7 trucks, let's use a tape diagram instead so that we can fill in amounts for these units. Okay, the other piece of information is the total, 192 vehicles on the road. So all of these cars and trucks together equal 192. Because we know that 192 is the total, let's dump that 192 into all of these units evenly, because the units must be the same amount each. Because we have 5 car units and 7 truck units, altogether we have 12 vehicle units. So let's take our 192 and divide it into those 12 groups. If we do that, we know that 16 vehicles will be in each unit. And to find out the total cars, all we need to do is take those 5 groups of 16 and find our product of 80. And to find our trucks, we simply do the same thing and take our 7 groups of 16 trucks and see that we have a product of 112. And so, though we started with a ratio of 5 cars to every 7 trucks, and the information that there are 192 total vehicles, we took our units of cars and trucks and we put them together to see how many total units we had. We had 12 total units. And because we knew 192 was the total number of cars, we dumped those 192 vehicles into those 12 units and found that there would be 16 vehicles per unit. Okay, so if there are 16 vehicles for every unit, and the cars have 5 units, then 5 groups of 16 is 80. And we did the same with the trucks. There are 7 units of trucks. Each one is worth 16. 7 times 16 is 112. Okay, but the officer wants to do a little bit more work. He finds out that for every non-commercial vehicles, there are 5 commercial vehicles registered and on the road. So our ratio of non-commercial to commercial vehicles is 14 to 5. If there are 108 more non-commercial vehicles than commercial vehicles, how many of each type were there? And so here's our ratio in tape diagram form. Here's our non-commercial with 14 units and our commercial vehicles with 5. The question is, if there are 108 more non-commercial vehicles, well, we could stop it right there. Let's label the units that are more than commercial 108, because non-commercial has 108 more than. And if we count those more than units, we see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. And so that 108 total can be dumped into those 9 units, giving us 12 in each. Now, because we know that each unit is worth 12, we can simply plug that in for the rest of the units in the problem. If we want to know how many non-commercial vehicles there are on the road, then we see 14 units of 12, which is a product of 168 non-commercial vehicles. And to find the total number of commercial vehicles, we have 5 units. Each unit has 12, so 5 groups of 12 is 60. There are 168 non-commercial vehicles on the road and 60 commercial vehicles. So remember, we started with the ratio 14 non-commercial to every 5 commercial vehicles. We were then told that there are 108 more non-commercial vehicles. And because of this, we took our non-commercial vehicles and we took away the total number of commercial vehicles to find out that more than number. 14 minus 5 would be 9. So we knew we had 9 units more of non-commercial vehicles. Well, 108 more than dumped into those 9 units was 12. And now we know that each unit is worth 12 vehicles. So non-commercial is 14 units of 12 each, and commercial vehicles are 5 units of 12 each, giving us the totals of 168 non-commercial vehicles and 60 commercial vehicles. Okay, let's talk about cell phones. For every 4 people that own smartphones, let's say 3 people own flip phones. But we learned that there are 500 more smartphones. So how many total smartphones are there? And how many total flip phones? Again, let's put our data down. We have smartphone owners, flip phone owners. We are told the ratio is 4 to 3. But because we are told that there are more smartphone owners than flip phone owners, we can locate all of the units that are more than flip phone, which in this case happens to be only 1. And then we could label that more than unit 500, because we are told that there are 500 more smartphone owners than flip phone owners. Now this tape diagram illustrates well 500 more smartphone owners than flip phone. And because we now know that every unit is worth 500, we can plug it in throughout the whole problem. And so we have 4 groups of 500 smartphone owners, we have 3 groups of 500 flip phone owners. Total smartphone owners would be 500 times 4, which is 2,000, and our flip phone owners would be 1,500. 3 units of 500. Let's quickly review. What have we learned by solving problems by finding equivalent ratios? For one thing, we've learned that depending on if we're being asked for part versus a part, or whole versus a part, or vice versa, we can come up with different ratios for the very same quantities. Using that information, we could solve things like how many cars and how many trucks are on the road if there's 192 total and the ratio is 5 to 7. We took the total number and dumped it in equally to all of the units. And when we've done something like that, all units being the same, because, again, these are equivalent ratios with the same relationship, then we were able to find the totals of each parts, like the total number of smartphone owners and the total number of flip phone owners.